we are asked to find the value of this indefinite integral. And some of you, in attempting this, might try to say, all right, is the numerator here the derivative or constant multiple of the derivative of the denominator, in which case u substitution might apply, but it's not the case here. So what do we do? And my hint to you would be partial fraction decomposition, which might invoke some memories from a pre-calculus class or maybe from an algebra 2 class. But it's a technique to break up this rational expression into the sum of two rational expressions. And a good hint there is the fact that this denominator here is factorable into these two expressions. So what we're going to try to do with partial fraction decomposition is say, can we express x minus 5 over 2x minus 3 times x minus 1, can we express it as the sum of two rational expressions, where the denominator of the first rational expression is 2x minus 3, and the denominator of the second rational expression is x minus 1, and I don't have to put parentheses there, is x minus 1. Now, we don't know the numerators. As you might have learned before, and I encourage you, if this is the first time you're ever seeing partial fraction decomposition, look that up on Khan Academy. We have many videos on it. But the general principle here is that your numerator is going to be 1 degree less than your denominator. So our denominators here are first degree, so our numerator is going to be 0th degree, or just constants. So it's going to be some unknown constant there, let's call that a, and some unknown constant b. And our goal is to solve for a and b. And this is all a review. This isn't really calculus. This is more pre-calculus now, or algebra. How do we solve for a and b? Well, let's add them as if we're just adding two fractions with unlike denominators. So we want to have a common denominator. So what we want to do is multiply this first rational expression by x minus 1 in the numerator and the denominator. So you could call this a times x minus 1 over 2x minus 3 times x minus 1. And then for this second rational expression, we'd multiply the numerator and the denominator by 2x minus 3. So 2x minus 3 times b over 2x minus 3 times x minus 1. And now, since I have the same denominator, I can add them. And the goal is when I add them and I think about the numerator, I will try to say, well, how do the a's and b's line up to what we have already right over here? So this is going to be equal to, same denominator, so the denominator is 2x minus 3 times x minus 1. And in the numerators, actually, let me do it over here. This is the same thing as ax minus a, just distributing the a. And if I distribute the b here, this is the same thing as 2bx minus 3b. And so if we add the numerators, we can add the x terms, ax plus 2bx. So we could call that a plus 2b times x. And then if we add these constant terms, minus a minus 3b. And since we have a minus right over here, I'm going to try to pattern match. So I'm going to have minus, and I'll write that as minus a plus 3b. If you distribute this negative sign, then you're going to get negative a and negative 3b. So these are equivalent. And now we can see the pattern. We can say, all right, our denominators are not the same. So this thing in our numerator has to be the same thing as x minus 5. So whatever our coefficient here is on x, that's got to be equal to 1. That's the coefficient on x. And this thing that we're subtracting, that's got to be equal to 5. And we're going to set up a system of two equations with two unknowns to solve for a and b. So we know that so let me write that down. We know that a plus 2b needs to be equal to 1. And we know that a plus 3b, or a plus 3b, is going to be equal to 5. And so now to solve for a and b, well, we could do that by elimination. So let's see, what if we multiply this top equation by negative 1? So that'd be negative a, negative 2b, negative 1, and now we add them together. The whole point was to cancel out the a's, so we're left with negative 2b plus 3b. That's just going to be b is equal to 4. And then we can substitute back in to solve for a. So let's say right over here, we know that a plus 3 times 4, so that's going to be 12. I'm using this equation right over here, is going to be equal to 5. Subtract 12 from both sides, you get a is equal to negative 7. So just like that, we can rewrite this entire integral. We can say this is going to be equal to the indefinite integral of, open parentheses, a over 2x minus 3. We now know that a is negative 7. So it's negative 7 over 2x minus 3. And then we're going to have plus b. b is 4. So plus 4 over x minus 1. Over x minus 1. And close the parentheses, dx. Now, if you are so inspired, I encourage you to pause the video and try to run with it from this point, because we have seen the techniques to solve integrals like this before, but I'll do it step by step. This is going to be the same thing as, actually, so this is going to be the same thing as the integral of, so 2x minus 3. I could write the negative 7 here, but I'm going to take the constant out of the integral. So I'll put a negative 7 here. And to help us solve this, and this could be a 1, but to help us solve this, it would be nice if we had a 2 here. Why is that? Because 2 is the derivative of 2x minus 3. And so then we can do our u substitution, which we have sometimes gotten practice doing a little bit in our head. And so if we want this to be a 2, we can't just multiply by 2. We've also got to divide by 2. And I could do that outside because that's just a constant. Dx plus, well, the derivative of x minus 1 is 1. So we just want a 1 up in the numerator. So we could take the 4 out of the integral. 4 times the integral of 1 over x minus 1 dx. So this is going to be equal to, we just have our constant out front, negative 7/2. And since we have this thing in the denominator and we have its derivative, we can really just think about this as integrating with respect to this thing in the denominator. You can sometimes view u substitution, which I'm not explicitly going to do here, as the reverse chain rule. The antiderivative of 1 over x is a natural log of the absolute value of x. But here, the antiderivative of this is going to be the natural log of the absolute value of 2x minus 3. And then for this part, this is going to be plus 4 times the antiderivative here is the natural log of the absolute value of x minus 1. And once again, I can do that because the derivative of x minus 1 is just 1. And of course, since we're taking an indefinite integral, we do not want to forget our plus c. And we're done.